Sonal Patel, Senior Associate Editor at Power Magazine and Content Director for our Connected Plant Conference. Thank you, everyone, for joining us for today's webinar, where we will be network breaches with secure vendor access management. Before we begin today, I would like to take a moment to review some housekeeping items. Please feel free to chat with us if you're having technical difficulties, and someone from our team will be there to help you. The slides from today's presentation are also available in the Handouts tab on our webinar platform. I think we're going to kick it off with a video. Thank you. Xona enables frictionless user access that's purpose-built for operational technology and other critical infrastructure systems. Technology agnostic and configured in minutes, Xona's proprietary protocol isolation and zero trust architecture immediately eliminates common attack vectors while giving those authorized users seamless and secure control of operational technology from any location or device. With integrated MFA, user-to-asset access controls, user session analytics, and automatic video recording, Sona is single secure portal that connects the cybersecure physical world and enables critical operations to happen from anywhere with total confidence and trust. So now on to the program. Today's presenter is Bill Moore, who is the CEO and founder of Sona, the frictionless user access platform purpose-built for critical infrastructure. Over the past 4 years, Bill has partnered with global manufacturers and integrators to bring more secure and efficient remote and mobile operations to industrial customers in more than 17 countries. With over 20 years of cybersecurity experience, here's Bill. Welcome, Bill.
Thanks, Sonal, and thank you, Power Magazine. So I'd first like to kind of talk about our solution in particular around OT and critical infrastructure and how that's different really needs to be redefined away from sort of your traditional IT enterprise access. So I'm going to start out and kind of sort of think about it from the traditional approach and what we're really bringing to this in our frictionless user access platform. And we use the term zero trust, and I'll get into that and how that really also applies for your vendors, since we're really going to kind of narrow the focus down as I move through this into vendor access and third-party access and why a completely separate type of platform is needed that fits operational technology and critical infrastructure. So really the first part of this and what we see in sort of enterprise IT is there is a lot of legacy technologies for encrypting the data communications such as VPNs or VDI. And some of these solutions such as a VPN, which has been around for going on 20 years now, it was really designed to basically encrypt data communications over the internet, but wasn't there to really protect local area networks, and especially not critical networks where a lot of very critical processes in the power generation and energy, especially, and being able to protect control room networks and so forth. So I'm going to kind of go into what we do there in terms of reducing the attack surface, you're replacing some of these legacy technologies and really consolidating things like jump servers and VPNs and legacy multi-factor authentication, file transfer capabilities, and being able to do that in a much simpler way, while also meeting regulatory standards such as NERC CIP, IEC 62443, NIST 800-53, and so forth, and how those also apply. And then we're going to get into really the granularity on the authorization to each of these systems and assets, that could be in the control room, for instance, and talk about role-based access and time-based access controls, and then really talk about how you need the plant level and the site level controls as well, because what really kind of is much different in critical infrastructure is there is maintenance windows, and there are things that are, if they're accessed during those maintenance windows, could cause problems, including safety to the public as well as the people at the plant. And then also, talk about how this is also has the ability to still integrate with your traditional IT log viewers, SIMs, security information event managers, and so forth. So to kind of first understand, remote access and why we're really talking about redefining it for OT, we need to understand what is the enterprise IT access. And this kind of illustrates that from sort of the remote user perspective. So you may have employees or OEMs or other vendors or contractors that need to have access to a critical system, be it an HMI, an engineering workstation, that may exist in the OT network. And so really the way that the approach initially for doing that is very complex and very expensive. So what we've seen in many cases is really kind of trying to forklift enterprise IT, which is really designed for hundreds of users or thousands of users, maybe hundreds of applications, and bring that into an OT environment, which is much more highly distributed, may have thousands or even tens of thousands of sites, where there may only be 2 or 3 or 6 systems, and there may only be a half a dozen users. So bringing all of this complex IT equipment like application jump servers, Active Directory, VPNs, segmentation firewalls, and so forth, works great in enterprise IT, but just doesn't fit the bill for OT when we're really talking about the distributed environment. And so, this creates not only complexity with the potential for misconfiguration, but also there's just not the resources, IT administrative resources on the OT side of the house, on the operation side. And not only that, but what we see in many cases is even with all of this security components that are kind of bolted together in that are brought into the OT environment, protocols such as RDP and VNC are exposed all the way out to the employee laptop that's trying to remote into the system, even through the VPN tunnel and so forth. So the attack surface essentially gets extended to the third party or the remote employee, even with the VPN tunnel, because the protocol itself is allowed to traverse out to that endpoint. RDP is the #1 attack vector for ransomware. So this is a really big issue on the untrusted network for users or remote users that are trying to come in. So how do we approach this? Well, we essentially collapse all of that infrastructure into one simple gateway appliance, and we essentially enable zero trust. And what that really means is to really provide the isolation, the monitoring, the logging, the user access recording. Kind of an analogy around that would be sort of a castle and a moat. You have this drawbridge, you let people into the castle, but then they can roam around the castle, then go into any room in the castle and so forth. Nobody's really watching them. Where, if you think about this from, say, an apartment building, you may have, key code to get into the apartment building, and then you go up the elevator, you have a key to get into your apartment. And then maybe you have a safe in your apartment, and then there's accommodations to the safe. So you have all of these levels of control all the way to get to the most critical, or the thing that you're trying to protect the most. And obviously critical infrastructure is that, right? It's essentially that safe that's in that apartment, that has levels of controls all the way to it. So essentially what we're doing here is we're providing all in one platform the multi-factor authentication And then we're also enabling the ability for third parties, your vendors, to be able to access this in a seamless way. So, one of the problems with enabling vendor access is the vendor may have a type of VPN client to get in, and then your employees have a different type of VPN. So this becomes, sort of a security engineer, or maybe even a CISO to CISO discussion to determine how to get this contractor or this vendor connected to the network. The way we approach this is everything is through the web browser. Everything is encrypted using an encrypted web session for the authentication. The user, the third party, just needs a multi-factor authentication token, whether that's a Microsoft Authenticator or a YubiKey, which is a hardware token that they can plug into their laptop or their tablet. So these are the types of things that enable a complete ecosystem of authentication beyond just your employees, to your third parties and so forth, vendors, contractors, and so forth, to be able to authenticate. The next part about this is really being very granular in how to connect to each individual system, and then putting in plant level controls. And I'll get into kind of break this down in a little bit more detail in the following slides. But essentially, the key part of this is being able to protect the protocol, keep that into the OT network, not allow a protocol like RDP to go out to the remote users. So we essentially break the protocol and just send back the screens. So kind of like Netflix, coming into your TV, you don't have the movie, it's not downloading to your system, you're just watching it, but all of that stays on the protected side of the network, on their network. So we're essentially doing that, sending back the screens, and then the user, you can decide whether the user or the vendor can view the screen in the control room, kind of read only, or they can interact with the screen and be able to troubleshoot and do work. So to kind of break this down, there are a couple of different ways that a vendor could come into a critical, into a power plant, for instance. One is kind of through the IT/OT network. A lot of things are moving towards sort of federated identity management. SAML 2.0, tools like Okta and so forth are federating that on the IT side. And then you would come into maybe an OT sort of NOC or SOC, and then there may be another level of multi-factor authentication that's there to get down to what we have as our CSG, or critical system gateway, which is kind of the last policy enforcement point before getting to that HMI in the control room or the engineering workstation or SCADA application or whatever it may be. So that's the one way, and it's really not trying to reinvent the wheel on the IT side, just adding additional layers of strong authentication and granular authorization to those systems. Now, the other way a vendor could come in is an OT only. So being able to provide, maybe it's a very remote site, say an offshore oil rig or a wind farm that's very remote, and being able to enable things like satellite communications for the communications, or cellular, depending, and then being able to provide that to the critical system gateway with multi-factor authentication to connect directly to the OT network. So those are kind of the two different ways, and then being able to put those controls at the OT network, regardless of whether it's an IT/OT converged network or OT only. So to kind of, unpack this a little bit more, when we talk about comprehensive vendor user access control, we really want to look at sort of the role-based access controls. So, can the vendor only access assigned assets that maybe the plant, manager, or maybe somebody within higher level within their organization is assigned them to access? Or do they have the ability to create connections to other assets? So these are roles where you can be very granular. And then the other part of this is the time-based access controls. So being able to set up maybe a reoccurring time window. So the asset owner, the plant manager at the power plant or manufacturing plant would look at this particular vendor. It could be, Honeywell, Emerson, Schneider, whoever it may be, and say, I'm going to set up for each one of these vendors, I'm going to set up a time window, maybe Friday they have a 4-hour time window from 10 a.m. to 2 p.m. And then you know that those assets during that time, are outside of the maintenance window, or maybe you work around when, or maybe that becomes the maintenance window for those assets. So those are things that you can do, make it reoccurring, or set up a one-time time-based access control to access the assets. And again, depending on the criticality of the assets and the policies that you have on site, maybe you want this person to be able to just look over the shoulder and only have read-only or monitor access to a particular screen in the control room, and then somebody at the plant is actually doing the work, and maybe a senior level person that's monitoring can walk them through, kind of looking over the shoulder, or you can give them write privilege to do that as well. Again, the other part of this is the site level or manufacturing site plant level access. And this sometimes could be, getting a file transferred. So maybe there's a particular system that you want to patch, and you want to say, I want to make this file transfer moderated. So somebody at the plant has to approve the file transfer, and then you can make it a one-way transfer. So you just assign the access permissions, you can kind of see in the screen, of the connection or the asset. And the protocol, you enable file transfer for that asset, and then you tell the direction. Is it to the asset or from the asset? Maybe there's a file from the asset that you want to get back, so you can have it unidirectional, obviously, from the asset as well. And then the additional check here is on moderated access. So this could be moderated file transfer access, or it could be moderated access to the asset itself. So down below, you kind of see a please stand by. That's a virtual wait lobby. So essentially, even though the technician that's coming in has the ability to authenticate, has the rights or the authority to connect to their asset, you still may want to have someone in the control room actually approve the access to complete the complete authorization to actually connect to it. So these are just very granular controls that you would see in critical infrastructure, or you should see in critical infrastructure, that you don't see in traditional IT, in the IT enterprise. They're just not needed. You're protecting data, sensitive data in a lot of cases in an IT network. You're really protecting the safety of people at these plants as well as the general public. So you really need to have these additional site level controls to make sure that nothing bad happens, right? So you can monitor what's happening, and also approve access or not approve access if it's within a maintenance window. The other part of this is being able to have the complete logging of what the user is doing, and then a connection history and the metadata associated with the session, right? Where did they come from? How long was the session? What was the platform that they used? Did they use a mobile platform? Was it Windows or Mac? What browser did they use? And then also be able to see what the user did. So we have customers that have actually recorded, senior technicians going through literally dozens of processes, and then they, so they can share that as a training for junior technicians to kind of understand how to initiate different checks, calibrations, and other processes. So this is obviously important, from a business perspective, from an operational perspective. It's also important from a forensics perspective if there is a cyber incident, and you want to understand who accessed which systems and what they did. This provides a level of fidelity that you don't normally see in terms of security. You're usually coming through logs. This can actually show, what they actually did on the screen, what keystrokes they put in, what mouse strokes did they do, and so forth, or mouse clicks. So yeah, we see manufacturing use cases. We see obviously being able to operate HMIs from remotely is a big part of this. We've also seen remote system patching as a big use case. Mobile operations. This is very interesting because, in very large manufacturing plants, there may be working on an assembly line for instance, and there's an HMI that might be a football field away, and you're doing a calibration, but you need to see that screen. So that's a long walk back and forth to do a calibration. So being able to bring that up on a tablet, on an iPad, for instance, and be able to view that screen and make sure that what you're doing on the calibration matches up to what you want to see on the HMI, for instance, is key. And some manufacturing plants are several football fields, so this can get very time consuming, and obviously this helps with operational efficiencies to be able to enable these types of things. We actually, on the power side, we actually have one customer at a plant where they're under an SLA. They have to get power onto the power grid, and they actually use an iPad, and they can start up the turbine from an iPad while they're doing other work around the plant and not necessarily have to do that from the control room. So these are all kind of efficiencies that we see. We also see point-to-point kind of connections. So if it's a large campus with a lot of manufacturing facilities, maybe you want to bring back control rooms from the other manufacturing facility back into one control room, so you don't need to have somebody manning that other control room. In a large manufacturing campus, there might be obviously more than one control room. So these are some of the things that that we see on the manufacturing side and use cases. And thanks very much. Any questions before I end here? Okay. Well, thank you very much, and thank you, Sonal, and everybody with Power Magazine, and thanks.
Sorry, I think I had muted my camera. Should I, Kim, do you want me to jump in again? And sorry. Bill, thank you for that presentation. We do have a couple of questions, and the first one is, how does protocol isolation protect against ransomware?
Yeah, so I think that the key thing to think about is, the data communications, in order to, when you think about an attack of ransomware, generally what happens is, a user gets spearphished, maybe through email, through text, or different ways. And through that process, malware gets onto that machine. And the idea with the malware is to be able to look for a way of communicating with systems that are on the network. So if we're installing a keylogger or things like that and trying to get a foothold, and that remote user laptop is the first way of getting a foothold for somebody that's executing a ransomware attack. Now, if there's no protocol to attack, so if in other words the user is connecting, through the Xona platform, through our critical system gateway, it's not there is no protocol per se that the user can ride into the network. So if they were able to get the credentials of the person using that username, password, and things like that, they could potentially compromise the VPN tunnel and then go all the way into the network. With Xona, we do not allow that protocol to traverse back out of the OT network, that critical OT network. We keep it, on that local area network, and then we strip everything but the screen from the protocol, and then we only send back the PNG images. So it's essentially just the screen scrape. So there's no way of, you can't use, those types of, you can't use screen scrapes to attack a network. You actually have to have a data communications protocol. So that's the way we protect it. It's a little long-winded, but wanted to kind of set the stage. Yeah. Yep.
Okay. There are two other questions we have so far. How do you provide third-party multi-factor authentication, MFA, to OT assets without cloud or IT infrastructure?
Yeah. So one of the things that we pride ourselves on is the ability to, operate outside of the cloud. We could operate in a cloud network as well, but being able to be disconnected is very important in the OT world. What we see the cloud being used for in the OT world is very, very limited. Normally, it may be something that is a one-way communication of data for statistical analysis or data analysis, and they're using cloud scalability for crunching that data, right? But in terms of the authentication and authorization to these critical assets, this really is operated normally out of a OT network operations center. It's kind of a hub spoke environment. So really what we want to do is provide a complete logical access layer that's not dependent on the cloud in order to not, protect that network and provide the same kind of multi-factor authentication. And really the best way to do that is to provide either a hardware token or to provide something like a Microsoft or Google authenticator and a TOTP authenticator that doesn't have to be, it's a time-based protocol, so it can be used in a disconnected mode as well. So those are the two kind of key ways of doing it and providing very strong multi-factor authentication and doing it all through the web browser, which really brings in the frictionless aspect of this, of not being able to have the mismatch in access methodology with having two different clients.
Thanks for that, Bill. Okay, the third question I have here is, I have several vendors who will be remotely accessing their systems. How do I ensure that vendor A can only see their systems and not vendor B? So it's a privacy question?
Yeah, and so we actually, when we talk about the granular authorization to these assets, if you think about, and this again if you think about legacy infrastructure, and one of the problems with VPNs and so forth is they provide network level authentication, but they don't provide the granularity to connect to each system. And that's why you have to install a separate piece of technology called an application jump server in order to provide that additional level of separation and connection to assets. And then you also have to have, the infrastructure with authentication. We have a complete logical access layer. So we have our own encrypted user database that we can utilize. I mean, we could forward to Active Directory as well, or LDAP, but if you don't want to, have that additional authentication infrastructure with Active Directory, you can just use us. You can have us doing that authentication, and then we assign each connection. We configure connection profiles to that critical asset, and then we assign that to the vendor that owns that asset. So when they come in, they're assigned only the asset that they've been allowed to access. So from a visibility standpoint, they're only going to see that asset. They're only going to see ones that they've been given explicit permission to use, to connect to. So that's kind of the way we do it through the process, and being able to control the complete logical access layer with our own user database.
Okay, I think that wraps it up for our questions here.
Okay.
We want to thank you all for joining us, and any questions you have submitted will be sent to the sponsors to follow up with you. Again, I want to thank our presenter, Bill Moore, for sharing this with his time with us. And again, thank you to our sponsor, Xona. We hope that everyone has enjoyed the webinar today. Remember that Power and Chemical Engineering magazines offer a full suite of knowledge sharing opportunities throughout the year, including webinars and podcasts. So thanks again for attending today's sessions, and have a great day.
Thanks.